How electric motors are made. Electric motors are essential components in countless devices, from household appliances to industrial machinery. Understanding the manufacturing process of electric motors provides insight into their functionality and efficiency. This document outlines the key steps involved in producing electric motors, highlighting the materials, techniques, and technologies used in their creation. 1. Design and engineering. The first step in making an electric motor is the design phase. Engineers create detailed specifications and blueprints that outline the motor's size, type, and intended application. This phase involves selecting the appropriate motor type, AC, DC, stepper, or servo, based on the required performance characteristics. 2. Material selection. Once the design is finalized, the next step is to select the materials. Common materials used in electric motors include copper, used for windings due to its excellent electrical conductivity; steel, utilized for the stator and rotor cores for its magnetic properties; insulation materials, such as varnish or epoxy, to prevent electrical shorts; permanent magnets. In the case of brushless motors, high-energy magnets are chosen for efficiency. 3. Component fabrication. The manufacturing process begins with the fabrication of individual components. Stator. The stationary part of the motor is created by stamping steel sheets into the desired shape and stacking them to form the core. Rotor. Similar to the stator, the rotor is also made from laminated steel sheets and may include windings or permanent magnets. Windings. Copper wire is wound around the stator and rotor according to the design specifications. This process can be done manually or with automated winding machines. 4. Assembly. After all components are fabricated, the assembly process begins. Stator and rotor assembly. The rotor is inserted into the stator, ensuring proper alignment. Wiring. The windings are connected to the power supply terminals, and insulation is applied to prevent short circuits. Housing. The assembled motor is encased in a protective housing, which may include bearings and other mechanical components. 5. Testing. Once assembled, the electric motor undergoes rigorous testing to ensure it meets performance standards. Tests may include electrical tests, to check for continuity and insulation resistance; performance tests, to measure speed, torque, and efficiency under various load conditions; durability tests, to assess the motor's performance over extended periods. 6. Quality control. Quality control is a critical step in the manufacturing process. Each motor is inspected for defects, and any non-conforming units are either repaired or discarded. This ensures that only high-quality motors reach the market. 7. Packaging and distribution. After passing quality control, the motors are packaged for shipment. Proper packaging is essential to protect the motors during transportation. Once packaged, they are distributed to manufacturers or retailers for sale. Conclusion. The manufacturing process of electric motors is a complex interplay of design, material selection, fabrication, assembly, testing, and quality control. Each step is crucial to ensure that the final product is efficient, reliable, and suitable for its intended application. Understanding this process not only highlights the intricacies of electric motor production but also emphasizes the importance of quality in engineering and manufacturing.